Hey guys, let's get started. All right. I think we have like 2 weeks left of the semester, something like that, of lectures and then presentations, right? Somewhere around that. Today we are going to do some scripting examples. Touch on that a little bit more. So we're gonna have a case and that we're gonna focus on. So I'll do a few like warm-up scripts just to kind of get our minds back into it, and then we're going to have a case that we need to solve. This is a much more difficult problem to solve, and then you guys will have to, I'll just do kind of let you get the code to work, and then you guys will have to like run this for a while in order to solve the problem, if that makes sense. But it should be pretty interesting. So actually I'll give you the question and then you guys can tell me how we can tackle this. It's in similar style of you're a sysadmin, something happened, what do you do? All right, so I think I placed this. So we are recording now. And this should be under Case Aurora. Case Aurora. Yeah. All right, so we're doing this one today. So you can see there's a lot of files in there. I also have files on GitHub. So pay close attention to this because there's a few little things that we need to look at. There should be a Word doc. Yes. Let's open the Word document. Okay, and I'll kind of, just start with that. I'm not really going to like lecture today. It's more we're just going to work on these problems and should be fun. All right, so few of the instructor demos, so the things that I'll do, some warm-up problems, simple HTTP, serve some files using the provided HTTP script. I'll go over that. I'll show you how to create, let's say you're somewhere at work and they're just like, can you create a web server for us for all these files, something like that. And you don't want to go through all the trouble. You can just spin up a type of a web server with a simple script and get going really quickly, right? For internal. Obviously, it's not an external web server. It's just an internal enterprise network kind of a thing. So we'll go over that. Here I wrote a little bit. So simple HTTP, serve some files using the provided HTTP script. If you don't want to set up Apache and want to have your own HTTP server, you can use the Python library simple HTTP server. This allows you to make any directory in your system into your web server directory. This can be useful for sysadmin to share files inside your local network. If index.html is present, then it will be displayed. Otherwise, you get a directory listing. So basically, the problem will be to create and run a web server that serves files from a working directory. Okay. All right, so we'll go over that one. It's actually super easy. Then we'll do PDF, just using the system information gathering script, create a PDF with the provided Python script. So you can use all of these once you've completed the GeoLocate example to kind of just show your data. So we're still kind of in this idea of the network operations center. So I showed you guys how to do SNMP and how you would have all these charts, right, for the homework assignment. Now you can add additional functionality like adding PDF reports, display it on a web page, etc. And then tar, back up some files and create a tar file. Also, if you've collected a lot of data and you just want to like back it up. All right. So all these three scripts you can integrate into your case Aurora, but I will just kind of demo these. As I said, case Aurora does take a little bit, so we may solve it today or it may go into Thursday. Okay. I can't remember exactly. All right. Solve the attached case Aurora. So it should be here. All right, so we're going to read through it. And that's basically what we're going to focus on today. So it should be like an interesting problem. So remember, you guys, sysadmin somewhere in a company, and you're faced with this problem. So how do you tackle it? So given the following case, propose steps you could take as a system administrator to address the given scenario. So this is called Operation Aurora and how the obvious was missed. So on January 14th, 2010, the United States learned of a coordinated, sophisticated, and prolonged computer attack that targeted Google, Adobe, and over 30 Fortune 100 companies. And there's the citation. Dubbed Operation Aurora after a folder found in an infected machine. The attack used a novel exploit unseen before in the wild. Although Microsoft knew of the vulnerability exploited in the attack, they falsely assumed that nobody else knew of the vulnerability and therefore no mechanism existed to detect such an attack. To exploit their victims, the attackers initiated the attack by sending the victims an email with a link to a German website with malicious JavaScript. When users clicked on the link, they would download a piece of software, or sorry, malware, piece of malware that connected back to a command and control server located in Germany. I have changed the name of the country so I don't get sued or something like that. All right. From there, the attackers used their newly gained access to hunt for proprietary information stored on the exploited victim systems. Okay. So as obvious as this attack appears, it went undetected for several months and succeeded in penetrating the source code repositories of several Fortune 100 companies. All right, so that's the problem. Now you're the sysadmin, right? And you need to think of what you could do to detect this attack, for instance. And not just detect it, but also prevent it or stop it. Let's say stop it once you've detected. Do you guys understand the question? Yeah? All right, so obviously it might, so I'll repeat, to exploit their victims, the attackers initiated the attack by sending the victims an email with a link to a German website with malicious JavaScript. When the user clicked on the link, they would download a piece of malware that connected back to a command and control server located in Germany. From there, the attackers used their newly gained access to hunt for proprietary information stored on the exploited victims' systems. Okay, so you're a sysadmin now. What do you do to stop this? Or detect it first. Yeah, Bob.
Well, I mean, just having more email filters on outside domains would help prevent that.
Okay, yeah. So filtering, yeah, spam detection, that kind of thing. What else? Do you think you can stop something like this? Like if you're a sysadmin and somebody just says, detect it and stop it. Do you think you can do it? Do you think it would be possible for you in that company to just sit down in an afternoon and detect it and stop it? Or do you need to go buy $1 million tool to do this? What do you guys think?
I mean, I don't think you can stop it in an afternoon, a week or two, maybe.
Detect it and stop it?
Yeah, I don't think it's gonna be done in an afternoon, but I don't think we need to go out and spend 7 figures on a solution.
Right. Probably we got to think outside the box, right? But there could be a vendor that says, yeah, give me $1 million. I'll do this right now. Right. So you got to really think about what's happening, right? What are the key? So all people want here is for this to be detected and stop. That's it, right? So there's a lot of things going on in there, but could there be a simple solution to this? You see where I'm going? So that's kind of like what this case is about. You know, that's obviously a Python scripting example, but it's also kind of to show you that, you know, there might be a simple way to think about this. So you guys understand that the malware here, right? What's happening? The malware is running on the computers, but it's connecting across the internet, correct? And we know from firewalls, you can't go in through the firewall if you initiate from the outside, but if you're in, you can go out, right? And that's the thing, somebody installed this program inside, so it can go out through the firewall, correct? But if we could find, so is it using network packets to communicate across the internet?
We have to, so you can figure out the ports it's using and the IP addresses, you can just block all incoming traffic from those ports and IP addresses.
Nice. Okay, yeah. So that's how to stop it, right? But first, you, as you said, you have to detect it. And that's hard, right? What do we know? What's like the piece of information that we have that's in that we know?
Source country.
What is the source country? Germany. So some people in these network operations centers might have a world globe kind of a thing, and they show these little dots of where the network traffic is going. Do you guys see that? If you don't do commerce with Germany or some other country even, right? And you see a little red dot there, you might wonder why. Do you see what I'm saying? Like,
break down network traffic by application. If you have one application that's constantly sending data to a place you don't normally send data to, that's a questionable program.
like another country, right? Like a country that's maybe questionable, right? Yeah, exactly. And so that's actually the one quick way of solving this problem is it's called geolocation. So basically the idea is if you can somehow scan your network traffic or even create a little map that you're always looking at in your network operations center, you know, it might highlight strange things going on and you might be able to detect it and zero in on it. Does that make sense, guys? All right, so yeah, great. So that's kind of, so obviously stopping it would be putting something on the firewall. So we've already done firewalls in Linux, and you know, so I'm not really going to address that part, but we are going to address the part of geolocation, okay? So that's basically what we're going to go through today. And then what you guys will have to do is, as part of the homework, is once this code works, you're going to visit countries, right? Like Japan, you can go to the University of Japan or somewhere like that, you know, Sweden, you know, wherever you want to go, right? China, etc. And then when you run the code, you should be listing those countries in the, and then there you go. It's kind of, that creates the data. And with that data, we can use it to display things, etc. All right, so as I said, now that you know this information, sure, you can do this in an afternoon, write this script, you know, put in some country where a lot of traffic is going and start to zero in on those IP addresses. Make sense? All right, so let's go ahead and start working with this. You know, I'll do some examples, as I said, just to kind of illustrate the four scripts that, you know, this talks about. And then we're gonna just get into the case Aurora. It's a involved script, so it's a bit more challenging. So, you know, but we'll work through it. All right, so let's start the virtual machine. We only need one VM today. Let's go ahead and start it up. All right, so let's go ahead and start. So this, one of the things this needs is like a database. So the database I think I provided on GitHub. So you'll need to download several files from there. Okay, we'll start writing this out. Just give this a minute. Right, here we go. So there are 3 scripts. One is the HTTP server one. I'll go over that one first. So right, so I'm going to call this one just Case Aurora. So here we are. So okay, let's go ahead and there's a function in Python. Let's see if this still works. Python -m http dot server 9000. Oops. Okay. All right, so now we need to go to a browser, I believe, on port 9000. So one. And there you go. You see that? So as I was saying, for the Case Aurora, you're collecting data, and then you can just like grab the data and display it on very simple website here. Does that make sense? So I'll just do like a very quick one. I'll add an index.html file in here, and I will also add a couple of files. So actually, I'll add a couple of text files first. So I'm gonna, since this terminal is running, I'm gonna open up a new terminal and navigate to desktop. And IPS72. That's no case. Okay. All right, so yeah, so let's add a couple of files in here. So I'm just going to say text1.text hello. Then I'll add another one, text2.text hello 2. Okay, so we've added the 2 files. Go to the, and you can see they are now being displayed in as a type of directory listing. So as I was saying, if internally You want to just, if you have a server, you want to set it up just real quick, you can. And then this could be accessed by anyone in your network without going through much trouble. If we click on this, yeah, you can see the text there. Now I'm going to add the index HTML file, which should then, show. So I'm going to say index.html. And this is, of course, if you don't want to go through the trouble of setting up Apache. I'm just going to put in some very basic content in here. HTML. Section. And the body section. And then here we can add like a paragraph. All right, and then you can just add, hello. Okay, so hopefully that should work. So now let's go to the page. And you can see it's now, because we put an index HTML file, it's basically a regular website. And from there, you can make it how you want. And it's just tied to that one server on a specific port number, obviously for internal use mostly. Like, for instance, when you generate your geolocation data, you can display it here. Does that make sense, guys? Any questions? So super easy, right? Did everyone get the command for this? It should be in the other term. And then it records, it's got like a log too, but basically I just ran that command. Got it? Everyone with me? Any questions? All right, great. So that should be it. All right. Yeah, so that one, like I said, the homework will just be one problem, the geolocate one, but just display the information in some nice way. Don't just like do a screenshot. All right, so we've done. What was the HTTP, the tar one? Oh, the PDF one. All right, so we'll try the PDF one. So there's obviously a lot that can be done with this. I'm just going to do something very simple. All right, so let's go ahead and try now to do a report. So I'm going to stop this web server, so I don't need any more. All right, so now let's do the second script. So, nano, let's call this PDF gen. Yeah. Gen .py. Oops. Okay. All right, so let's try something called report lab. What we're going to do from report lab dot PDF gen import canvas. Just like that. All right, so let me see if that library works. No module report lab. Okay. So go ahead and try to install it. I'll do pip install. report. Mhm. Now this should work because you guys already installed Anaconda, correct, on your Linux devices. You already know how to create environments. If you don't want to do it on the base, go ahead and create your own environment as we discussed. So you know how to create environments also. I just did it here. Any questions so far? Making sense? Okay. All right, let's try the script one more time. All right, no errors this time, so that's good. So I'm going to go ahead and do clear here. Right. So now basically we can, again, so the theme here is we're going to create a file with information to solve the case Aurora. And you can generate a website, PDF report, and actually index it on that same website for people to download. All right, so let's go ahead and try. You probably want to justify how you did it, etc. Okay, so let's go ahead and create a function here. I'm just going to call it hello, like hello world. And I'm going to call it down here, hello. Yep. So 1, 2, 3, 4, define the indentation. Let's create an object. So I'm going to say C equal canvas dot canvas. And I'm going to call it hello PDF dot PDF. Okay. All right. So, oops, sorry. Then I'm going to say C dot draw string 100, 100, hello world. Okay. And we're going to say C dot show page and C dot save. All right. So we're just going to try that out. I'm going to do Control X. Enter. Python. Okay. We created a file called hello pdf.pdf. Okay. So now I'm going to go to the browser. I'm going to go to the desktop. I'm going to go to spring 2024. Case Aurora. Hello PDF. And I wrote something. I don't know if you guys can see it. It's written right there. And you can play with this. So that's kind of what I'm going to show you for now, because this would be very involved. Okay, so later on, I'll come back to give you a few pointers, etc., on how to define this. So basically, these are just a couple of examples. So again, when you do your lab, we're going to solve case Aurora and then just show that you'd like deploy that little website, created the report with just some information that you gathered about the geolocation. Does that make sense? All right, it's just one problem, basically. So now let's get into the geolocation problem. As I said, this one is a little bit involved. It's gonna involve PCAP files. I think I have an example of a PCAP file already, so with data in it, but you guys will have to collect this on your own, okay? So maybe through Wireshark, for instance, okay? All right, so now that I've done this, I'm gonna download some of these files from my own GitHub. Okay, so I'm gonna go ahead. Oops. go here. This one's still running. I'm going to close it. I'm sorry. Now I'm going to open up browser. Going to go to GitHub. Okay. Mhm. Another way of getting to GitHub. I'm going to go to the course repo, which is this one, Unix and Python. So that's the URL right there, right? And I have in here a folder called GeoLocate. Okay, so you can click on that one. I think I updated this last semester, so it should be up to date for today's class. All right, so I have several files in here. I would just recommend just download everything and then we'll sort through it. But basically, there's going to be like the PCAP files, some data, as you can see, some more data. There's the script. We're going to write this one. And there's this Geo1 and Geo2. These are basically probably the databases that we need. Okay, so we need to have like a database that knows IPs and associates them with countries and cities so that we can do the actual, we do need that, okay? We do need some kind of way of looking up IPs and determine what country they originated from. And you guys will verify that this works because for your homework, you will, as I said, open up Wireshark or TCP dump, visit some sites all over the world, and you should see those through the script so that you can identify where your network traffic from your home or the school was going to. Okay. All right. So let's go ahead and get started. I think, we can just, where's the thing? I guess I may need to download the whole Unix and Python. I think nowadays because nowadays I think GitHub lets you download individual ones. Yeah, that's too much work. All right, let's just download the whole thing. You can delete it later. All right, so you can just click on this green button if you don't know, right? And then download zip, right? Everyone with me? All right, so once you've completed that, save. Then you can go to the downloads folder. Go to downloads here. And it should be this one, right? Yeah, so extract here. All right. So that should be this one now. And we just need, I guess you're going to need this Docker one also when we do that one. So don't delete everything. All right. So go to GeoLocate. Yeah, this one. All right. So I'm just going to copy the whole thing. And I'm going to move it to the desktop where I'm working on this problem. Case Aurora. Yeah, here's one. All right, so now we should have a lot of the databases that we need. So we're just going to then start writing the script. And the idea is we would collect the PCAP files. The PCAP files need to be fed to the script, and the script is going to do all the processing for us. Okay, so now let's go back to the terminal. Do an ls-l. We can see GeoLocate is right there. Okay. So let's get started. Raise your hand if you have any questions. GeoLocate. Go here. So I'm going to create script geolocation script .py. Okay. All right, so it shouldn't be that bad. So we're gonna need a few libraries. So I'm gonna say import socket. Import, these are all things that we're gonna need for network connections. I'm gonna use a package called dpkt. Okay. Then we're gonna import geo IP and also from geo IP import GeoLite2. We may not need all of these. Yeah, sorry. Oh yeah, sure, sorry. Yeah, so we may not need all of these, but you know, might as well have them. All right, so from GeoIP import GeoLite2. All right, so I'm gonna add separation here. All right, so oops. So basically what we need is we're going to want to have maybe like a dictionary of IPs to countries. We're going to need a way to read in those geo databases like geo1.dat and geo2.dat. So we can try to use PyGeo for that. Then basically we just need to be also write a script that allows us to iterate through the PCAP files. All right, so we want to grab all the data in the PCAP files. We are going to use dpkt for that, similar to what we did with Scapy. If you remember with Scapy, we were able to grab the different headers of a packet. You know, we're doing something similar to that here. Okay, to break them up, etc. Yeah, so that's basically it. Okay, so I'm gonna start kind of where, you know, at the bottom here, I'm gonna create this area called the main, fake main area. All right, so basically you would first, you know, just say here, need to visit some websites in other countries. Remember also, although you'll probably be visiting new countries you've never been to, remember if you have visited you know, websites in other countries already, those things may be cached in like, you know, caches in the United States, for instance. So then you may not be able to see the effect. So probably you're gonna, and that has nothing to do with your own cache, right? So that would be like a server cache somewhere. So you probably need to visit countries you've never been to before, you know. So it's not, and you know, so hopefully that'll work. So try or universities or rare places. I think in the past, visiting universities like in Japan or, you know, has always worked. Okay, so try things like that. Things that are not that common that might, you know, DW news may be cache problem. All right, so let's go ahead now. Once you need to visit some websites in other countries and collect PCAP files, which you guys know a lot about now because you've done all the Wireshark assignments. All right, so now let's go ahead and open up. I think I have a file in there called test1 PCAP. So I'm going to try to read that one. It just has some PCAP data in it. And we're going to see if that works. So I'm going to do F equal open. F open. Yeah. So test one dot PCAP like that. All right. And then we're going to say the format of that file is bytes. So for some reason, I guess to be efficient, so then you need to say RB. Yeah, so that's a common thing. for binary files. All right, so now we are going to try to read it with DPKT. I think I used the same VM last semester, or yeah, last year. So I may already have all these libraries, but it's very likely you guys wouldn't have these libraries. So dpkt dot pcap dot something called reader underscore f. That. Okay. So, and then once you do that, I'm going to just run it, see what happens. So Python, no module name dpkt, pip install dpkt. Okay, let's try it. Still clear. Let's try it again. No module PyGeoIP. Install PyGeoIP. Okay, all right, try it again. No. Yeah, so that one I believe we don't need, so I'm not going to install it. I'm just going to comment it out. This should be this one. Right? Okay, so let's go ahead and try it again. Control X, Y. There. All right, no errors. So, and we should have the libraries. So we should be able now to get going. Any questions so far? Making sense? All right, so now let's go ahead and do the next part. So once you've read so let's go back to the script. Once you have read the PCAP file, right, you have it in memory. So, this is something, how could you collect these PCAP files? I think you've had several problems throughout the semester, right, of creating cron jobs where you would invoke TCP dump, right? You remember that from one of the assignments, and then you would just be collecting all this data and, placing it in the var log or somewhere like that. But in this example, we're just going to assume we have a file in here. So now we need to process this PCAP file. So I'm going to go ahead and create a function called print PCAP. Okay, and I'm going to provide to this function the PCAP file, just like that. All right, so then I'm going to define here. So I'm going to say def print PCAP. Right, and that's going to be PCAP. Okay. So that's basically that. Now, 1, 2, 3, 4. And we just need to know how to break out of the PCAP file all the individual packets, break them up into the headers, process the data so that we can basically check the IPs for the geolocation. All right, so let's create a for loop here so that we can iterate through the PCAP file. Okay, so in this function here, I'm going to say for this returns a buffer, a tuple with an item, comma, buff. All right, so we're iterating. So we're going to say for those two items each in PCAP. Okay, so let's go ahead. Let's just first try to print these. Let's see if if they print. So 1, 2, 3, 4. I'm going to do print item. Okay. So Control X, Y. All right, so we have some information there. Okay. But really the information we need is the information contained in the buffer. Clear. Let's take a look at buffer. I think buffer is going to have a strange structure. Okay, so let's go ahead and, yeah, so what does that look like? That's hexadecimal. That's why I said you're reading this as a binary file. So this is why it's not a text file, and we need the dpkt library to process it. All right, sort of like Scapy. So let's go ahead and go back into it. So now, print is just, I was debugging, so we don't really need to print it. So now, let's go ahead and, these things can give you an error sometimes. So we want to have an exception handling just in case something breaks with, it's network data, right? That was collected, so it could have errors. So I'm going to do try except. So what this does is basically, if there's an error or something, it's just going to ignore it and keep going. You don't want to go through 10,000 packets and just have it break once it gets to 998 or something. So basically, also sometimes you can have like a counter in here to know how many errors you had, for instance, right? So we can do 1, 2, 3, 4, error equal error plus 1. And then in the end, we can print it. We probably need to initialize here. 0, right? So every time there's an error, we print. You can also print like a message, maybe. Print error. And then finally, in the end, 1, 2, 3, 4, we're going to do error. Print error. Or print, yeah, sorry, this should be a string. And then this one should be the counter, so it's print. Number of errors. Comma error, like that. Just so that we can keep track in case we found errors and give us an idea of how many we had. All right, so now in the try is where we want to actually process the packet data in the buffer. All right, so I'm going to do 1, 2, 3, 4. Ethernet equal dpkt. So again, this is another network processing package. You've learned Scapy already. It's possible you could do this with Scapy. Okay, dpkt dot ethernet dot ethernet. Okay, and we provide in here buff, which buff is a buffer of the packet itself, packet information. We're iterating through all the packets collected. Okay, so let's go ahead. And from now, we need what? So if you remember, a packet has an Ethernet header, an IP header, a TCP header, and all of that. What we need right now is the IP header. So I'm going to do equal Ethernet.data. Okay, so that should give us some information. So let's go ahead and run this, make sure there are no errors. Okay, number of errors 0, so that's a good thing. We know it went through all of them, nothing to report, and so we got a little bit of functionality going. All right, so now let's go ahead and Keep going here. Now we need the IP addresses, of course. So I'm going to say source equal, and then we're going to use that socket function. So socket dot. The data in is going to be, so actually, let me print this. I'm going to do print from IP. We know that the IP header should have the source, right? The SRC, which is the source IP. So let's take a look at that. See if it errors out, because we may need to convert it. So we have it, but it's in a type of a hexadecimal notation. So we're going to need to change it basically. So we're going to use the socket library to be able to do that. So I'm going to go ahead here. I'm going to change this one. Okay. So I'm going to do source equal socket dot init and TOA. And this should convert it into something that is more readable. So then I'm going to go ahead and add it here. So now I can add IP dot source. I can repeat this for the destination. So I can do DST equal socket dot init underscore in TOA IP dot destination. Make sense? All right, so we have our two getting the IPs. Let's try this, see if it errors out. Clear. Okay, no errors, good. So we can keep going. So at this point, we are ready basically to process these for geolocation. So we do need the database for it. So I'm going to go ahead and need to define a new function. And we also need to look at both the source and destination IPs. Okay, so I'm going to say, I'm going to create a function called ret for retrieve geo string. Okay, and basically I need to define this one, and the goal of this will be to compare all these IP addresses. So I'm going to say here SRC and then geo string, and this one should be for the destination DST. Got it? All right, so basically we should be good. Now we need to define that function. All right, so I'm going to go ahead here. Now that function requires the PyGeo database, so we also need to create that. So I'm going to go here and create that as a global database, basically. I'm going to say the file is what you download it from, right, from GitHub. So you can say GI equal PyGeo IP dot geo. Oh yeah. Oh, did I do that? Okay. Oh, there it is. Thank you. All right, so PyGeo and then GeoIP. So we're going to invoke the database geo1.dat. Okay, so let's run this. Okay, so Control X, Y. Error. Number of errors 50. Oh yeah, because it's calling that retrieve library. Okay, that's why it's giving me the error. I was just trying to see if this would work, but I have no retrieve geo function. So I need to add that first. All right, so I'm going to go here. And I'm going to define retrieve geo string. Geo string takes in an IP. So let's call it the IP. Okay, which is that source and destination that's coming in. All right, and let's just do an operation. So 1, 2, 3, 4. Let's just do I equal 1. That should run. All right, so now let's try it again. Okay, no errors. You see, so that's good. Loaded the library, the database. So now we can proceed to try this out. Okay, so in here now, let's once again use the try in case there's an error. Except just print error. 1, 2, 3, 4. Print error. Okay. And then here we're going to invoke 1, 2, 3, 4. So let's see. Res equal g dot I country name by address. And I'm just first going to just hard code an IP address in here. So let's just do 14.139 dot 61.12. All right, so let's just try that just to kind of illustrate how this would work. That should give us something, so we need to print that out. Okay, so let's see. Print res. Okay, Control X, 9. India. You see that? That's basically how it works. So now we need to change this, obviously, for the PCAP file, right? But just wanted to illustrate how that would work. Okay, so if you guys have any IPs that you know of other countries, just let me know. We can try those as well. All right, so let's go now, and we need to change this to take the IP instead, right? So I'm going to comment this one out, actually. Okay, so then res equal gi dot country name by address. Okay, so let's add the IP here. IP. Okay. Yeah, and let's print res. So Control X, Y. Here. United States, United States, United States. Okay, so I guess I didn't visit any. All right, so you guys, of course, what you need to do in your lab assignment is you need to go to websites outside, collect that PCAP, say beforehand, I went to this university in Japan or something, show the screenshot of it, and here it is. Does that make sense, guys? All right. So obviously it gives you a lot of traffic of the United States. So we want to filter that out. Okay, so So it's because there's a lot of data in there. So let's go ahead. Let's go, clear. So we are going to try now to filter out certain, well, obviously the US traffic if you don't think that the attack came from the US, right? So, all right, so then res would contain, so we can say something like if United States in res don't print. I think it's if not. One, two. Okay. All right. So let's try. If not United States in res, print res. Still creates a line. Why did it do that? These must be blanks. There must be a lot of blanks in there, possibly. So that's what I think it is. So let's see if I'm right. So we need to clear that out as well, because otherwise it'll be very hard for you to find country. So let me print. Oh yeah, let me do this. I'm going to print the length of this, see if it tells me that it's 0. So then I'll know that there's a lot of blanks in there, because I really don't know what it's displaying. Yeah, so it's printing a lot of things that are 0. So we want to filter out that as well. So I'm going to do here. If len res not equal to 0 and not United States in res. So then print. Let's see if that works. Okay, better, right? So it went through, and I don't seem to have anything in that database from another country. I do have another one, some data PCAP. I'll try that one next. And notice I have two databases, Geo1 and Geo2.dat. So you should try both. So let's, oh, what was the name of it? Some data PCAP. Okay. Let's try this one. Open. Some data PCAP. Come on. B. All right. So I'm trying that now. Clear. I don't have anything in there either. So I must not have any visits to foreign countries. However, I did show to you guys that if you I hard coded an IP here, and if it's belongs to a foreign country, it'll say what it is, like Japan. Does that make sense? Got it? Yeah. All right, let me try one last thing. I'm going to try that Geo2. Now, the reason why I have these databases is actually this used to be free and open source, and nowadays for the updated database, they want you to pay or something. So I don't know the actual price of it. So what I have here is like smaller ones, but obviously we saw that it will work for Japan. So let me try these just in case. Oh, so there you can see I did have, for the other database, I did have some IPs in there from other countries. There you go. I kind of suspected as much. See, now it's really nice because it's no longer showing the US. It's only showing foreign countries. So it's showing Mexico, showing Canada, Mexico. Yeah. Got it? And we can try the other one also. For the other, so yeah, so there you go. Perfect. Okay, so we're using Geo2, so I'm just going to change to the other file. The test one, can't remember honestly what I recorded here. All right, so let's try this one also. Yeah, so apparently it was the other one would record things. Got it? Everyone with me? So that's basically geolocation. Let me get my charger. All right. So hopefully you guys understand the task then. And we can go back to the case. Let's go back to the case now. So it said on the case, how the obvious was missed. So although if we first look at this problem, it seems quite complicated, but once you start thinking about it, there are ways to figure things out. And in this particular case, something as simple as having geolocation in your enterprise could have been sufficient to detect and avoid this huge problem they had there. So this is a well-documented case for sysadmin, in Python. Any questions? Pretty easy, right? All right, so I'll create an assignment link for this one. And like I said, you need to go visit some countries and collect them. All right, so now, obviously some of the management of this problem would be that you're going to be constantly collecting PCAP files, right? You're going to have a cron job. You'd be collecting these PCAP files on a daily basis. And then you're going to need to display them in an organized way, kind of like you did with this script. But we also want to get rid of the files somehow. So that's that last. So we're going to look at the script related to backing up some files and zipping them. So you might want to just create this and then move it to some hard drive or something like that. Okay, so let's take a look at a simple example of doing that. I mean, if you can see that completes the geolocate specifically, all right? And you don't need to spend $1 million on an application that some vendors trying to sell you when you can just write this code from scratch and, and achieve the same objective, basically. All right, so let's go ahead now and take a look. Yeah, so now I'm going to back up some files, just show you a simple example. Okay, so I'm going to start a new script. So before I close this script and move on to a new one, are there any questions? Did everyone get everything? Got it to work? Yep, all right, good. All right, so now let's go ahead and let's do ls-l. All right, so I'm going to now let's say I'm gonna need some files to back up. So I may use like a full path, or I think I'm gonna use the temp folder actually. So whatever I have in temp folder is for this scenario. So let's take a look at temp. So I'm gonna go into temp, tmp. Okay, so I'm there now, ls-l. So there's a whole bunch of files in there, right, that you can see. So we're just gonna use this as the example for backing everything up. And we're gonna create our script for that. So I guess exit out of here. Yeah. And I'm gonna open it. All right, so we're gonna create a very nice zip folder, tar folder, sorry, that allows us to collect the data, put it all in the same place, back it up, and then you can easily move it off to some external hard drive or something, or however you want to do it. All right, so let's navigate. Desktop. Okay. So let's go to ITS 372. Spring. Case Aurora. Yep. All right, so let's start. So call this, we'll call it backup tar. Backup tar script. Okay, .py. All right. So let me go ahead and... All right, so let's once again, just like before, I mean, the script is simple enough. Some of it is familiar to you, like sub process you can use. We're gonna try to document where, when this was zipped. So we're gonna attach a date and timestamp to it. We're gonna need some libraries. So let's first see if the libraries are available. So I'm gonna do import tar file, import OS, import subprocess, and from date time, we are going to import date time. Okay, so let's just try these out, see if we need to install it. So I'm going to run Python. All right, no errors, so the libraries are available. So now we need to do several things. We need to first find the folder, selected folder. Then we're gonna need to walk that folder, find all the files that we want from there, and we're gonna start adding them to a tar object, and then that tar object will generate, and that's gonna contain everything for our backup. We also need to give it a name, and the name is going to be related to the timestamp. Okay, so we're going to start with that probably. So let's go back to the script. When I write these scripts like this, I have a tendency to write these lines. So let's create, first of all, let's get the date and time. So date time dot now, right? I'm going to go ahead and just print that, take a look at it. Print. Okay, so Control X, Y. There you go. So that's the date and time. So today is April 2nd, 2024. There's the time. And so basically this will serve as our timestamp. Okay, so we're going to convert that to string and attach that to the name. So we can comment this one out. So now I'm going to say string date time. And string okay, we're going to invoke date time dot now. Like that. So now we have the date and time. Let's replace any spaces with an underscore, given that we're going to use this as a name in Linux. And I don't generally, it's not right. I mean, I don't think it's recommended to have spaces and names in the Linux file system. All right, so I'm going to do date time. Make sure it's like that. So it's going to be equal. So string date time dot replace. And we're going to replace with underscore. Okay, just like that. And we've used this before, I believe. Okay, so that should just give us the name. Then we're going to create the name using this that we're going to give our tar file. So we're going to say tar file name equal string date time string underscore date time. But let's add something in front of it. Let's just say temp underscore backup, for instance, backup. Get the timestamp in there, and then let's just give it an extension dot tar. Like that. Make sense? All right, so once you've done that, we can create the tar object using the tar file. So I'm going to say tar, and we're going to assign, so we're going to invoke here tar file, the tar file library, and we're going to say open. Okay, and then tar underscore file name, comma, write. We're going to write to it. Okay. All right, so that, then we need the folder. So in this case, I have selected folder equal TMP. All right, so what we need to do now is that we're going to have to walk that folder, collect all the data, and then basically generate. Got it? Any questions? Pretty easy, right? All right, so now let's, I like to run this just in case I just spot some errors. Okay, no errors, that's good. Let's go back. All right, so now the part of walking the folders that we need, this could be like going back to the geolocation one, just backing up all those PCAP files that which could be pretty big, right? Pretty big. But in this case, I'm just going to keep it simple. So I'm going to do for root, comma, directory, comma, files in os.walk selected folder. So this function provides everything that we need to be able to iterate. So now I'm going to do selected folder. Yep. Like that. Okay, then I'm going to do 1, 2, 3, 4. And now we can do for file in files. 1, 2, 3, 4. And we should now be able to iterate through it. First, I'm just going to print. I just want to see what, that I have some file names in there. So I'm just going to do this. So hopefully that should give us a list of things. Yeah. Does that look right? coming from the temp folder. Ph.D. EMP. /L. Oh, some of those are directories. And then there's config error. It's a directory. So files gave us oh yeah, I'm in the wrong place. Okay, so we're back on the desktop. So it is 372 Spring. All right, so get back to case Aurora. Oh yeah, sorry, Bob. Really? Oh, I don't know. I don't think I'm touching anything. Yeah, there. All right. Yeah, so let's and you can see it already created a few tar objects. Just because every time I run it, it's creating blank ones. You can see the value here is 0 right there. Okay. So now let's go ahead and yeah, there we go. All right, so we can print also the dir folder. And control X1. And that looks like the directories, right? You guys look at it, kind of looks like a directories. All right, so you can see that it gives you all the pieces that you might need to iterate and walk the system. All right, so I'm just going to do a very simple walk here with the root and the file. We can also we should iterate through root or print root, sorry. So let me do that as well. So I'm going to go in here and now print root. And just take a look at what's in there. There you go. And mainly it's giving you folders, basically. There's a dot in some of these. Do you know what that means when a folder has a dot in front of it? It's a hidden file, right? The hidden file. So that's, those exist in Unix operating system. And they're security things, configuration things. Okay. So let's go ahead now and finish it basically. So we can wrap up this script and create our tar object. If we do ls here, you'll see there's quite a few instances because, we've been running this, but every single one has a different timestamp. And that's the nice thing about this is that you can start to create your backups with the timestamp and you can, like checkpoints, etc. in time. So if you needed, let's say you find an instance of a breach, you can always go back to that data by timestamp and kind of take a look at, look at it in more detail, use Wireshark for your analysis, etc. since we were collecting PCAP files. All right, so now I'm gonna go ahead and just try to finish this one. So we need to load the file, so I'm gonna just do this. I'm gonna comment this out actually. And we're just gonna say full path. So I'm gonna create a variable full path. And I'm going to use OS. So I'm going to say os.path.join. And I'm going to join root and file. All right, so we have the full path basically. And those are the things that we are going to be saving in this scenario. So now it's quite simple. You can just say something like tar.add. And in here, we're going to add full path. Okay. Oops, sorry. And finally, once you've created the tar file, maybe you're just, you're collecting, you have a folder where you're collecting all your PCAP files, and those are the ones that are being processed. But once you run the tar file, you move them out of there and dump them somewhere else, right? Such as the desktop. So in this case, I'm going to add a command in here, command. And I'm just going to, use subprocess. So I'm going to say mv, which is the move command in Linux, tar file name, comma, and, for this example, I'm just going to move it to the desktop just to show you guys that they do move from this folder to the desktop, basically. I'm going to do home seed desktop. And if we're successful, it should appear there. So this is the command list. So we have to invoke subprocess. Subprocess dot call. And we're going to provide the command itself. All right, so now we should be ready. So you can create the timestamp, select a folder, walk it, grab the files that you want, add them to the tar object, create the tar object, and then move the tar object out of there in this case, so you can back it up, basically. All right, so let's go ahead and run this one. Let's run ls-l first. We got the 4 ones. Okay, no errors. So that's a good sign. Still have the 4 ones. Okay, so we want to look for that tar file in the desktop, and you can see it's right there. Does that make sense, guys? Any questions? That's it. All right, so basically that's the whole application of the GeoLocate. Remember, the cron job, you should be able to figure that one out. You're running a cron job periodically, scanning your network, creating these PCAP files. Then those PCAP files get analyzed by another cron job that runs the script. The script analyzes for countries, and it creates some reports if it finds them that you can store in your website that we talked about, create a PDF, etc. You have a whole nice little report system, and then run another cron job probably, right? And do the backup the old PCAP files, and ship them away. Maybe you would want to only do this for certain files, possibly, right? So you'd want to check by date, etc., because some of them may still be current ones that need to be processed. But that's getting into too much detail. But that should that's a whole complete I would say pipeline of a solution, and this is security, right? In the sense, it's cybersecurity, geolocation, and I think this solves quite nicely the case Aurora. I mean, so if you wanted to take it a step further, you could create a map of the world, put little dots where the countries are, and things like that. But that's more like web development or something. All right. Any questions on the case Aurora? So this completes it. Just as I said, all you have to do, use these scripts that I provided to you to generate the whole pipeline, basically. The key thing is you need to collect your own data, visit some countries around the world, and then show that you were successful in that. But all the scripts should be working. On Thursday, we're going to cover other topics, okay? But we are done with this example. It's just a nice little case. Are there any questions? All right, so I'm going to go ahead and create the link on Brightspace for this one. And it'll be a week from Thursday. It's a week from Thursday. We may get another homework assignment on Thursday, depending on how it goes. Yeah.
Doesn't the wire chart readings do it at the same time?
Yeah, the wires. Yeah, but this one you've already, you already have. You just have to collect the data. And the Wireshark reading, yeah, you're right. So that would be like 3 you're saying, right? So we may not have a, but I'll see how it goes. Okay, yeah, that's a good point. All right, I'm gonna create the assignment link here. And if you have questions, bring your computer so I can take a look. Do you have a question? Uh-huh.
So I'm kind of confused what the lab is.
I did post a video though.
I didn't see one in my sub box.
There's no. Did I post a video for last the SNMP? Didn't I do the whole thing? Yeah. Yeah. All right, I'll take a look again.
Okay.
So what you have to do is you have to, it's for the whole lab, right? Is your question?
Mhm.
All right, so you configure the SNMP client. Let's see what I get here. Wait a minute, where did you get this? Oh, I see what you're confused about. We didn't do this one.
Okay.
So that's your question, right?
Yeah.
Yeah, we didn't do that one.
Okay.
So you don't have a homework one.
All right.
But let me, so do you have to do, well, the homework is to do this one.
Oh, okay.
You know how to do that one?
I'm pretty sure. I think.
Yeah, and then SNMP and web, we did not do.
Okay.
So you can just ignore it.
But still do the Wireshark reading.
Yes, the other, if it has an assignment link, you have to do it.
Okay.
But this one does not have an assignment link, so we just didn't do it.
Okay. Thank you.